All right. First of all, thank you again to Ben. That was.
I am Vitalik Buterin, co-founder of Bitcoin Magazine.
How has your day been so far? Yeah, Sophia, how has your day been so far?
I gave a talk at the Istanbul Institute of Technology. Yeah, it was a great talk.
Wait, I gave a talk at that same institute.
Wow. Wait, are we in the wrong seats? Okay, we haven't prepared this bit. So anyway, welcome y'all. We're gonna do it. Wait, I forgot. I left my cards. I don't even know what I'm gonna talk about. No. Okay. So, in all seriousness, we're here. Optimism, talking about scalability. Thank you very much. Talking about scalability, I think a good way to kick it off is, what is the importance of scaling Ethereum, of scalability in general? Yeah, take it away, Carl, MEB.
Yeah, so who here has used Ethereum in the last week? Who here have paid a transaction fee of less than $1? Who here has paid a transaction fee of greater than $10? Who here would love to be like someone in, let's say, Ghana and have to pay a transaction fee of $10 every time you use Ethereum? Yeah, see, like, basically I think scaling is just important because fees are way too high, and fees are especially way too high if we want to make Ethereum usable by a much larger group of people than people that are already in this room. And in order for fees to be higher, it's like basic supply and demand, right? If you want the price to go down, supply has to go up, and so we need to have more block space that people can do things in. And like that is, to me, what scaling is about.
Oh, it's been a long journey of scaling, Lord. But I mean, how would you describe the kind of arc of Ethereum scalability? What's it been like?
Yeah, so I started thinking about scalability all the way back in 2014, and even in 2015 and 2016, I remember there were all of these kind of early researches into sharding that we were doing. There was this. Like there was this big. Like there was this.
Did it work?
I have no idea if it worked. So there was this big paper on sharding that I wrote back in 2015, and we talked about like splitting the Ethereum chain up into vertices of a hypercube, and these vertices of the hypercube would all talk to each other, and then how you could have like a hub and spoke system and have 2-layer scaling, and then eventually go up to 3-layer scaling. And like really went through the possibilities of like trying to like basically create this kind of hyperscaled layer 1 that would abandon the property that constrains blockchains today, which is that everyone needs to verify every block, but achieve like maintain the properties of security and decentralization, and at the same time make it a more distributed system where you have different nodes that are verifying like different blocks and different transactions in different parts of the chain. And so there was this big long strand of layer 1 scaling research. And then at the same time, there was this other strand of layer 2 scaling research, which basically said, well, instead of making Ethereum itself much more powerful, but at the same time more complex, let's build layer 2 protocols that sit on top of the layer 1 and benefit from the layer 1's security. But basically try to make these layer 2s be much more scalable than the underlying layer 1, but still maintain a security property where if you have a thing inside of a layer 2, you can always go and like exit that thing back to the layer 1 whenever you want to. And so you could have transactions that happen inside of the layer 2 that actually reflect changes of ownership in the underlying assets that are issued on layer 1. So there was state channels. Who here remember state channels? Then in 2017, there was this paper from Joseph Poon and myself on Plasma. Who remembers Plasma? And then in 2019, we started seriously talking about rollups. Who here remembers rollups? Yeah, so 3 families of layer 2 scaling solutions that have, and I think a lot of the momentum recently has been on the rollup side, but we can talk about the other families a bit later as well. Like we basically, I think what the space has really ended up converging into is also realizing that the layer 1 and layer 2 scaling endgames in a lot of ways end up being fairly similar in that it's like you end up replicating the same type of structure. The difference is basically like where do you draw the boundaries of like what is one system and what is another system, and you essentially have a trade-off of like independent innovation versus more like homogeneity. And it's been interesting to like see that evolve and to see the scaling vision for L1 kind of co-evolve, moving away from doing sort of formalized sharding and toward data availability, sampling, and trying to kind of be a backbone for layer 2s. Yeah, I mean, there's just been a lot of work since then, and I think the really big thing in 2023 is just how much work there has been on getting these proof systems actually working, so that we have like real scaling with security coming to fruition.
Nice, nice. So it has been almost 10 years of trying to scale this thing. What makes it so hard, and how far along are we in that journey?
I mean, scaling a blockchain is hard because blockchains provide these like really strong security properties where any individual person can verify that they have a state which is completely valid, which is the result of rules being correctly followed, and which has this really important property of data availability, meaning like if they want to do something themselves and like send a transaction or something, then the data actually exists to allow them to do that, right? And like just the state being valid by itself means nothing if the data is hidden, and so you can't actually like make a transaction and actually spend the coins yourself. And so like you're trying to achieve all of those things, and achieving all of those things, you can understand how you can do it if you can like every single participant downloads and checks everything by themselves, which is what blockchains have generally been doing so far. But once you start asking the question of like, how do you preserve those properties? How do you get this guarantee of correctness without actually even having the data? Like, how do you know that a thing is correct and that a thing is correct everywhere while only downloading possibly small parts of the thing? Like, that's really spooky. And there are a lot of these really fascinating mathematical building blocks that make it actually a lot more possible to do that than any of us thought possible years ago, but it's like still a pretty complicated journey.
Nice. And I mean, you started talking about the implementation details, and you mentioned state channels, plasmas, rollups. What's the TLDR? And I know we were talking about some things around plasma. What's the latest?
Yeah, and so plasma so the way that I categorize state channels, plasma, and rollups is if you take away deposits and withdrawals, because deposits and withdrawals always involve the L1, then how much data goes on chain, right? In a state channel, 0 data goes on chain. Like I can pay you inside of a channel, and all of that is just messages between me and you. Nothing goes on chain. Plasma is O of 1 data goes on chain, so lots of us can do transactions between each other, and a Merkle root goes on chain. Rollups are O of n data goes on chain, so a little bit of data for every transaction, but the amount of data can be much less, and all the computation is still off chain. So 0, O of 1, O of n is the difference between the 3. But as you go higher and as you put more data on chain, the level of generality that you can support becomes stronger. So if you have O of 1 data that is on chain, the really nice property that you get is you get a property where if the people running the layer 2, and like if all of them just disappear right now and all that's left is you, there is enough data that is on chain that you can just go and continue, and you can personally start continue the layer 2 from there, right? And like that's a really powerful property that rollups have that makes it really easy for them to be very general purpose. In Plasma, the data is off chain, and the problem that comes then is like, well, what happens if the operator disappears, right? The only thing that you can do is like users have to exit. And Plasma has a greater dependency on there being a particular operator, or which could be an individual, could be a multisig. Like you cannot do Justin Drake's sort of code-based rollup thing where anyone can go and submit a layer 2 block, because if someone submits even one like Plasma block where data is missing, everyone has to exit. And this is not really avoidable, right? Well, there are ways to avoid it in some constructions, but even that requires everyone to just wait for a week and not be able to do anything, right? So it's the cost of a bad operator is higher, and then there's like this much more complicated incentive game, because like it's individual users' responsibility to exit and to exit on time. And individual users have to have the choice of whether or not to exit. And that requires every single asset inside of a Plasma system to have like a specific owner that then who is responsible for making the decision to exit or not. And if you start going into more complicated applications, so things like Uniswap, for example, or CDPs, where you have like an owner, but the owner has debt, and like it's not clear who owns the debt, then things get much more tricky, right? So that's and then the other big challenge with these Plasma systems is like when you worry about the possibility of invalid data, then there's the game to like how you exit in the case where there is some invalid data becomes even more complicated. And I think one of the really interesting things that I've been thinking about recently is like, now that we have ZK snarks and ZK EVMs are getting better and better with every passing month, could we potentially make much better Plasma systems where you still have some problems, but like you have much less problems than you had in the constructions from 3 or 4 years ago. So yeah, I think that's just an interesting set of questions to think about, right? And I think now that we're getting into this world where it's becoming clear that there's kind of different tiers of data availability, it's then we're getting into this interesting situation where you have rollups, and then you have things like Validiums, and you have other things on top. And I think ideally everything should be either a rollup or at least a Validium of some kind, because like once ZK snarks are cheap, everything should have a snark of it. But then the possibilities for increasing security for things that don't have data fully going on chain really start increasing as well.
Nice. Yeah, we started out as Plasma Group doing, focusing on that whole off-chain stuff, and then, of course, realized the generality of roll-ups was going to be incredibly important, and we were seeing a huge amount of applications in that kind of space. But what kinds of applications do you see as things that are not possible in the roll-up context that may be, unlocked in the Plasma context, or even other solutions?
Yeah, I mean, one of the interesting sets of applications is just that, the entire space of centralized stuff that wants to explore going decentralized in different ways, right? So there's the enterprise blockchain space that tried going into consortium chains for between 2015 and 2019, and then consortium chains just kind of quietly ended up failing, right? And even all of the CBDC projects that explored being a consortium chain at the beginning just kind of quietly turned into basically being servers. And then now, there's also the autonomous world stuff that 0xPark is doing. There's all of this, ZK GameFi stuff. There is, and then, on the enterprise side, supply chain applications, and then different kinds of non-financial applications, sort of different kinds of assets that have lower needs for security, assets inside virtual worlds, assets inside communities, all kinds of different things. And for those, the amount of data that all of those need is just massive. And so even if full dank sharding is not going to be able to support all of that data, and so having all of that be inside of some kind of Plasma-like system, I think, could be super interesting, right? Basically, I think like the correct compromise between centralization and decentralization is not to have a consortium chain, but it's to have a thing which is still centrally run, but which plugs into the Ethereum base layer and commits hashes and proofs into the Ethereum base layer for security. So I think there's a lot of interesting possibilities there.
Nice. I am very excited for that future, but in order to get to that future, we're gonna need to build it. So one thing that we've been tackling a lot is like, okay, we have this open protocol. How do we actually, create it? How do we create it in a transparent way that is inclusive and all that kind of stuff? So I was curious, Vitalik, you're obviously very involved in the core development process for Ethereum. Like, what is that process? How does that work? And yeah, just give us some interest.
Yeah, I mean, so changes to Ethereum are done through this process. It's called EIPs, Ethereum Improvement Proposals, which are modeled on BIPs, which are Bitcoin Improvement Proposals, which are themselves modeled on PIPs, which are Python Improvement Proposals. Basically, the idea of an EIP is like someone makes a proposal, and there's like a document that you go and make, and it's an EIP document. There's like a standardized format where you have different sections. You describe the proposal, describe the motivation, describe the specification, and then you like as the kind of the pusher of the EIP, it's also your responsibility to like organize the implementations across all the different Ethereum clients. And then there is this fortnightly call called the All Core Devs call. And in the All Core Devs call, like often what happens is you go through a list of EIPs, and sometimes EIP, like we just talk about EIPs, and sometimes EIPs get accepted. And this call includes people from the Ethereum Foundation, it includes people from all of the client teams, it includes like independent Ethereum researchers and developers. So basically like significant contributors to the Ethereum core research and development ecosystem. And then at some point in EIPs get accepted, and then they get chosen for a particular hard fork, and they get implemented. I think what's interesting is like most of the time, nothing is contentious enough that like this proposal was not good enough, right? Like sometimes there are technical disagreements, but like even when there's technical disagreements, there's not enough technical disagreement for people to kind of not be okay with just going along with whatever the result of this process is. The only big exception, I think, has been these proposals to do things that have like a big economic impact or sometimes kind of philosophical impact on what Ethereum is, right? So the DAO fork was one example. Then EIP 999, which would have rescued the parity wallet, where because of a bug in the contract, there's about 300,000 ETH that got stuck. And there was a hard fork proposal to rescue that money, but that there was a bunch of like community level discourse happening on that. And there was even this platform called Carbon Vote, where people who had ETH could vote with their ETH for or against this proposal. And there was just like a heavy sentiment toward the no side across basically all of the channels. And so EIP 999 ended up not getting implemented. There were decreases in the block reward. There was also obviously the switch from proof of work to proof of stake. Though that one was, I think, easy because it's just something that got telegraphed so far ahead of time that people knew that it was coming. Yeah, like for things that are like of that level of seriousness, then like generally you escalate to sort of some higher level of like making sure that you have community buy-in. Yeah, but otherwise it's like the EIPs, they go through the EIP process and then they get accepted.
Yeah, how do you navigate those controversial decisions to that kind of do dictate the future of Ethereum? Like what is that governance process?
I mean, if you want to dictate decisions, you got to have a dictator, right?
That's right, Vitalik. You heard it here first.
Yeah. So when are you putting on your crown, Carl?
No.
No, I mean it's. Yeah, I think as like what's basically happened in practice is like when a decision is controversial enough, then it just naturally escalates into community discourse, and people try to like end up creating these sort of sentiment gathering channels, which are sometimes like you vote with your ETH, sometimes it's social media voting, sometimes it's GitHub like upvotes and downvotes, and just like go across a whole bunch of different channels. And like, this is something that totally could be done way better in 2023 now that we have like popes and zoo stamps and GitHub passports and like all of these fancy mechanisms. But you know, before that, like, even without that, like, there's just enough of these community sentiment polling mechanisms, and generally it's just clear whether things lean toward a yes or a no. And like, there's always a possibility that even that fails. And like, you know, Ethereum Classic has happened, and it's always possible that some crazy fork is going to happen 10 years in the future as well. But like, so far, I'm not seeing anything that could possibly lead anywhere close to that. Yeah, so that's Ethereum, basically how governance has worked so far. Like, basically, I think we just have this really nice property that decisions kind of either are technocratic decisions that have to do with like technical improvement, where most people don't have deep feelings on them, and it's just like they're okay with trusting the kind of expert core research and dev consensus. And there are decisions that like really touch upon economics and values, where like on, you know, the core researchers and devs are generally just like happy to defer to what the community sentiment is on an issue, and like they will often make strong arguments and write blog posts and go on Bankless podcasts, but you know, like ultimately it is a community decision. So yeah, I think like that approach actually has turned out well over time.
Nice. And one contentious decision that I feel like we've not, that maybe we've pushed to other layers is public goods funding and how that is actually going to happen. So yeah, first off, I guess, what is the importance of public goods funding, and why can't, you know, why is Ethereum governance maybe not the place to solve it, or, you know, maybe it is, whatever.
Yeah. I mean, the Ethereum ecosystem depends on lots of work that produces outputs that benefit the entire Ethereum community, but where there is no way to control on a fine-grained level which people don't get that benefit and which people don't, right? So like, if you think about like ChatGPT, like if you pay the $20 a month, you get the GPT-4. If you don't pay the $20 a month, then you don't, right? But if you think about like the research that goes into making ZK snarks possible, like that is out there. Like, there are blog posts, there are PDF papers, there are code implementations, and there is no way to like exclude people who do not pay a 20-a-month subscription from benefiting from that knowledge, right? And so the problem is that like there is no good natural business model for creating that knowledge. And I think so far we've had that knowledge being created because of a combination of funding from a pretty small number of projects, goodwill from a lot of community members, a very kind of public spirit toward you know, like openness and decentralization from a lot of key players in the ecosystem. But like, there isn't a really kind of clean institutional approach to like really making sure that kind of funding happens sustainably in the future and across all of the different sectors, right? Like, even today, you know, like Ethereum spends like how much was it? It's 26 million ETH staked, and so we're getting about 4%. Multiply those two, about a million ETH a year. I think a little bit less on proof of stake rewards. So like, the Ethereum ecosystem spends about like $700,000 ETH per year, so like over $1 billion a year on security, but then it spends like 10% of that on R&D, right? And if you think about it, like having maybe $300 million less spending on security and $300 million more spending on R&D would like actually probably be a much better trade-off for Ethereum as an ecosystem, right? Like, we don't benefit nearly as much from the last 30% of our security as we do from the having like 4x more work on making like things like ZK snarks possible and better, right? But the challenge is like, for security, it's easy to identify in a credibly neutral way who to give the money to, because like, you give the money to people who stake and deposit and make blocks, and you can cryptographically verify who made the blocks. But with public goods funding, it's an inherently subjective question of like, which public goods are good in the first place, which public goods are public in the first place, and like, you can't have an in-protocol mechanism that verifies those things automatically. And so there's this like really challenging question of like, well, which layer of the ecosystem is the appropriate layer for funding these things? And I think it's like super important for this ecosystem to solve this problem. I mean, both because if we don't solve this problem, then the ecosystem will just be much less capable of serving its users than otherwise would be. But also because I think solving the public goods problem is really important if we actually want the future of this ecosystem or any part of the world to really remain open and decentralized, right? Because a big reason why things become more centralized is because things that are centralized have more obvious business models, right? Because like you can hide the information and you can give the information only to people who pay you $20 a month. And like if you're a decentralized thing, you cannot do that. If you have a centralized thing, then like you can make people who view the thing go through your interface and you can put up the ads. But if you have a decentralized thing, you cannot do that, right? If you have a centralized thing, then like you can go and announce like, hey, we're increasing the fees by a factor of 10 tomorrow, and like no one can complain. If you have a decentralized thing, that's harder, right? Like all of the routes for having a business model are just like much more available if you build a centralized thing that like restricts users and that pulls people into an ecosystem that is closed and where you gain more power over your users than in a decentralized ecosystem where making money is significantly harder, right? I mean, and so if we actually want like products that and services that reflect the values of freedom and openness and decentralization to like actually be adopted, they have to be at a competitive quality level to the centralized offerings. And for that to happen, we need to figure out alternative sources of funding for them. So this is the big challenge, and I think and one of the big reasons why I really respect the Optimism ecosystem is that it's actually like doing a really a good job of like trying to directly tackle those challenges.
Oh, well, thank you. And I mean, I was going to ask, how do we solve it? Because we do want we do want that future. We need that future.
So I hear that you guys are doing this like round where you do like funding things, but it's retro in some weird way, and you're already doing the third one. So maybe you want to talk about that.
Oh, wow. I mean, yeah. What is this, Carl?
What is it?
Okay.
I'm asking the question.
Okay. I mean, yes, we are on the third round of retroactive public goods funding. It is, I mean, you can see the kind of thing that Ben talked about where, we're making things that are otherwise very impactful but do not make profit, like open source software, like the Ketchak library, that we are funding those projects so that there's an incentive to build for the public good. Now there is another component here, which is it's really important that retroactive public goods funding is complemented by an open source and decentralized protocol that promotes forkability, that funds, provides actual funding for that. And that's what this kind of whole law of change thing is about, right? We want to make sure that at all points, there's a way for, there is a clear system. We're not just giving out retroactive public goods funding without actually showing that impact is met with some kind of real tangible, value added into the system. So it is, we got to build that thing and fund public goods, and yeah. And thank you, V, for getting us here and coming up with the whole public goods funding. Retroactive public goods funding thing. Oh, we got some questions. Great, so I can stop rambling. All right, from Anonymous, question. The use of ZKP and full dank sharding is going to impact the storage of L2 data in L1 nodes. Can DA protocols help to enable that vision with validity proofs?
I'm not sure what this means. Actually, is the person who asked this in the audience? Can you try to elaborate more? Yeah.
Maybe this is an opportunity to describe the difference between validity proofs and data availability, and those two very separate problems, which you alluded to in the very beginning.
Right. Yeah, and so what dank sharding does, right, is it creates data availability proofs, which basically, or data availability sampling, which lets you verify that large amounts of data, like in full dank sharding, the goal is 16 megabytes per slot, are actually available, which means like you can actually download them if you want to. And availability is like a really important property because it means that if you know that data is available, then like you can actually go and perform some computation on that data yourself if you want to. So if, for example, you want to make your own transaction that and like spend your own coin, then you can go and like see and you can check that, and you can go and like create the transaction that spends your coin, and there isn't any missing data that prevents you from doing that, right? Validity proofs are a separate mechanism that is about proving that some function over a piece of data, which could be available, could not be, it could be not available, right? So validity proofs don't do anything about availability. Computes and results in some particular value, right? So like, for example, a validity proof might say, this piece of data represented by this hash is an Ethereum block, which is valid, right? And a validity proof can just go and prove that statement. So validity and availability are kind of two different problems, one of which solve missing data attacks, and the other of which solve invalid data attacks. And those are different kinds of attacks that both need to be handled. So I see them as attacking different parts of the problem.
Cool. And it ties into all of those different L2 scaling solutions, state channels, plasmas, and rollups. Cool. And I promise this is probably the best question that we have anyway. Anyway, sorry. For Vitalik, do you view Superchain plus RPGF as a valid solution to fund the R&D funding gap for Ethereum? AKA, are we doing okay?
I think so.
That's great to hear. Well, you heard it here, folks. We're doing good. I think that's it for the online questions. Are we out of time, or do we have good to go? All right. Yeah. Well, thanks everybody, and thank you V for joining us. Woo.